Today, we are going to use a slinky to demonstrate the behavior of sound waves. When talking about sound waves, the vibrations of particles are best described as longitudinal waves. With longitudinal waves, the particles are pushed together and pulled apart by vibrating objects. The energy of the push and pull radiate out. High pressure pushes and low pressure pulls are what cause sound. Our ears are designed to hear these alternating pushes and pulls, or waves. Depending on how an object vibrates, we hear changes in the sound. Volume is based on the size of a vibration, or its amplitude. If a vibration or amplitude of the wave is small, the wave won't have a lot of energy, so the pressure will be slight and result in a soft sound. If a vibration or amplitude of the wave is large, the pressure will be more intense and result in a louder sound. Pitch is defined as how many pushes and pulls hit your ear every second. We also refer to this as frequency. Sounds are a higher or lower pitch according to the frequency of the vibration of the sound waves producing them. Here's a diagram to show the difference between pitch and loudness. The pitch of a sound depends on the frequency, while the loudness of a sound depends on the amplitude of the sound waves. So to review, sound energy travels in waves that are measured in frequency, or the number of sound vibrations per second, and amplitude, or how forceful a wave is. The energy of a sound wave can be measured using decibels. The sound sensor you'll be using today will measure the sounds you create in decibels. What is the relationship between sound waves, sound, and energy? This is waves and energy. Sound waves are formed when a vibrating object causes the surrounding medium to vibrate. A vibration is a quick back and forth motion. A medium is a material which a wave travels through. A medium could be a solid, a liquid, or a gas. As sound waves move through a medium, the particles around them vibrate backwards and forwards. I'm going to demonstrate that now. Pretty cool. A sound's volume is how loud or soft it is. We measure the intensity of a sound in decibels. Today, you will use various mediums to investigate how they create sounds. For this investigation, you will need a wireless sound sensor. For part 1, you will need a tin can with a balloon stretched over the top. Make sure you don't have any latex allergies. And then we're also going to have a couple paper clips. For part 2, we will use a plastic food container with several rubber bands stretched over it. Resembles a guitar. Then you'll need some paper and a cup with water and a straw. Okay, so for part 1, we're going to use the balloon drum. So for this demonstration, we're going to put a couple paper clips on this. And then I'm going to hold it up and talk under the can to see if I can get the paper clips to move without touching them. If you're doing this in your classroom or at home, it helps to have a partner watch for you so they can get but we'll just go ahead and get a close-up of the action for you. Okay, move, 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 move. Hello, hello, hello. Using your observations, you will answer questions 1 through 4. You can pause the video to complete these or move on to part 2. Okay, so for part 2, I'm going to connect my sound sensor to my device and choose sensor data. You'll see here that it automatically has the sound wave turned on. We want to turn that one off because we're going to be using the sound level sensor, and I chose sound level A. Then you're going to click on the line graph to give you sound over time. And again, the sound's going to be measured in decibels. All right. First thing you're going to do is take a sheet of paper and hold it up over your sound sensor. And in a second, I'm going to start collecting data. And for 30 seconds, I want to make as much noise as I possibly can with the paper. All right, let's do it. All right, it's been 30 seconds. That was actually a lot of fun. All right, I'm gonna go ahead and make sure to name this run for you so it's easy to reference. And I'm just gonna label it paper. And then your job is to look over the graph and find the loudest sound that you were able to create with the paper. All right, you can pause the video to do that now if you need to. Make sure to also fill in your observations. Okay, so we did the paper. Now let's move to the cup with the water and the straw. And again, I'm going to hold this over the sound sensor and for 30 seconds, make as much noise as I can. If you decide to blow into the straw, make sure you're not making any noises using your voice. All right, here we go. All right. 30 seconds complete. All right, let's save this run. We'll just name it water. Okay, and for your last one, you're going to need to get the guitar, and I'm going to strum it for 30 seconds. Again, trying to make as many loud noises as I can. All right, let's do it. Okay, well, I will not quit my day job as a science teacher and become a musician anytime soon, but that was certainly fun. All right, I did my 30 seconds. I'm gonna label this one guitar. All right, so again, like you did the first two rounds, I want you to research the graph and find out where you have your loudest sound and put that into table 1. And again, pause the video if you need to. Okay, so we collected our data. Now it's time to analyze it. And I want to take you back into SparkView and show you how we saved these all under the name of the tools that we utilize. So I have my paper run here, I have my water run, and I have my guitar run. If you want to show them all overlaid, you can do that. But remember, you're being asked to mark the highest level in decibels that you were able to get for each piece. So if you want to find a data point, so this one's pretty easy. I can tell that that's 90 decibels, but what about this one? All you have to do is make sure that the graph is turned on. So I have this clicked here. Click on the data point you want to review, and it brings up this coordinates tool. You click that, and that'll show you the decibel level at that point of data collection. All right, so to answer the questions in your student lab sheet, you will want to refer back to the demonstration at the beginning of the video, as well as your observations and data from part 1 and 2.